or the other way around. Function notation. You're lucky we're not doing shorthand notation. Do they even teach that anymore? Shorthand? When you're in a law court, they try to document everything that goes on, and this is going back years before we had technology. Now they probably video it. But there was a lady in there, and it wasn't a typewriter, it was a shorthand notation machine. And everything was recorded. What he said, what this guy said, what the judge said, click, 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 it's all in shorthand. It's a special form, so it's a lot quicker than actually typing out every single word on and on. Emily? Why do you need a pencil case? Borrow one. I have one. You're a big girl, you make a choice. All right, part one, tomorrow's part two, okay? So, last day we did some mapping stuff, okay? We don't need to read all this, but it looked like that, okay? Nobody does that. In grade 11, okay, in most math courses, well, I'm going to say all that I'm aware of, we use function notation, not mapping. So if you saw that, we played around with it last day, which was like 4 days ago, so it's probably gone, because in a 15-year-old's life, that's like 1/10,000th of your life. 4 days, right? So anyway, you did this, I hope. Okay, if I tell you what x is, you plug it right there, and you find out what this f:(x) stuff is, okay? Just like in a graph. If this is a graph, well, how do you plot the points? This is some function. You don't know this yet, but that's the equation of a line, okay? And if I tell you, well, x is 5, that's the value of the, is that independent or dependent? Independent. Is that domain or is that range? Domain. That's the domain. Is that the input or the output? That's the input. I'm saying all the same thing. Why do we have 4 ways to say it? I don't know. Okay, I'm just here to teach it to you. Okay, so if x is 5, in this function, what is the value of y? You substitute 5 for x. You find out what your output is, what your y value is, what the dependent value is, okay? Maybe this is an equation of someone riding their bike, and I want to know at 5 seconds, I'm serious, 5 seconds, where are you? This is time, y is distance, okay? At 5 seconds, put it in. 2 times 5 is 10 plus 3. I'm 13 meters down my driveway, okay? 5 seconds later, I'm pretty slow, okay? No, give me a break. Okay? Last day we did this mapping. It's exactly the same thing. It doesn't say y. It says this mapping thing, f:(x). Okay? You substitute 5 where there's an x. You found out f of 5 was 13. This is what we're doing today. It's no different. This is a function in terms of x. In my example, it's the distance. Okay? If x is 5, you plug it in, and f of 5 is 13. Okay? That's function notation. We say f of x. Where does it say that? F of x. Okay? That's what this says. It's a function in terms of x. We give you x, you find out what f is for that input of x. Okay? That's it. It's just substitution. All right? F of x. That's how we say that. It doesn't mean f times x, right? This is the name of the function. The function in this case is f. F for function. But we could have used all sorts of different letters. Okay? Like g of x. It's still a function in terms of x. All right? So, f of 3. You see how this says f of x? We want to know f of 3. So what do? Where there was an x, now there's a 3. So I substitute 3 in this function. Hold that thought. Bathroom. Hello. I can give it to it, yeah. Okay, thanks, bye. All right, f of 3. So this is the function, x squared plus 5. So wherever there's an x, I'm going to put in 3. Grease the bottom of that thing, would you? Okay, so 3 squared plus 5, right? All I did was substitute. It's not x, it's 3. Wherever there's an x, if there's more than one x, you put it in every place. Then you do some bed maths. What's 3 squared? That's 9. What's 9 and 5? That's 14. Okay? 3 seconds later, Leon is 14 meters away from his seat. Okay? Where is he at 7 seconds? I don't know. Let's go look. No. Okay, g of 1. I've got 2 functions here. I got g of x. I got f of x. This says g. Hey, g for g. Which one am I going to use? I'm going to use that one. Okay? I don't want g of x. I want g of 1. So where there's an x, I put a 1. Okay? So 4 minus 1. And I know we can all handle that. That's about 3. Okay? F of minus 2. I look at my f of x function. What's x here? Negative 2. Plug it in. But be careful. Is that correct? Or did I forget something? Anytime you substitute, Alicia, what do I need? Brackets. It's not negative 4, it's positive 4. That's the difference, right? Okay, plus 5. I still got plus 5. That's 4 and 5. That's 9. So here my time example doesn't really make any sense. But I guess, I don't know, if I'm firing a rocket off, I could have t minus 2, right? T minus 1, blast off. We don't usually have negative time, but it doesn't matter. Okay, g of minus 2. I'm going to put g of minus 2 in my g of x function. 4 minus. Anytime you substitute, you should use brackets. Okay, it's not 4 minus 2, it's 4 minus minus 2, which means we add those, and that's 6. Okay? Combination of things. I have this function. And I'm going to do something with that function too. So f of 0, I'm going to plug 0 into this function. 0 squared plus 5, right? I don't have to bracket it. I'm just doing that for visual. Minus, I got g of 0. What's g of 0? 4 minus 0. Okay? So we could ask lots of stuff. We could add the 2 functions together, maybe multiply them, maybe do something more complicated. Okay? All that's saying is I want to subtract this function when the input is 0 from this function when the input is 0. I'll just write it down. Okay? 0 squared is just 0, so I have 5 minus 4 take away 0 is just 4. What's 5 take away 4? All that stuff is just 1. Okay? Okay, just a couple more. Get a bit bigger, a bit more complicated. What does this say again? Who wants to take a stab at that? Don't yell it out. That has to do with domain, right? What does that say? I said don't yell it out. No volunteers? All right, Tyrell, what does it say? X is the set of all real numbers, okay? Everything. Fractions, decimals, rationals, irrationals. All right? Consider this function, f of x. There it is. Okay, what is f of minus 3? I don't know. Let's find out. Input minus 3 wherever they have an x. This is 5x cubed. So 5 times minus 3 cubed minus 2 times, now I just got to put it in two different spots, okay? If x is there 19 times, you put it in all 19 places. Okay, bed mass, what's negative 3 times negative 3 times negative 3? That's minus 27. That's times it by 5. And negative 2 times negative 3 is plus 6. So what's 5/27s? 5/25s is $1.25, and I got 5 times 2, which is 10. So that looks like 135 negative. Everyone agree? Okay, what's minus 135 and 6? Minus 129. Okay? Now, x is 2. 5 times 2 cubed minus 2 times 2. That one's worded a little differently, isn't it? It doesn't say what's f of 2. It says what's the value of f, this function, when x is 2. It says the same thing, right? That says the same as this, if it was f bracket 2 bracket. Okay, they're just wording it differently. Okay, that's 8. 2 cubed is 8 times 5 is 40 minus 2 times 2 is 4. That's 36. And this is that image arrow stuff. You know, it's in our book. It's not something totally important, but this says exactly the same thing as this. What's f of 7? Okay, the image of 7 under f. Okay, I'll never say that in grade 11. So just plug in 7 wherever there's an x. Okay, 7 times 7 times, that's just too big to even worry about, okay? All right, what's f of a? It's exactly the same thing. Wherever there's an x, you put an a, right? So 5 times a cubed minus 2a. Is anybody telling me what a is? No. So that's all I can do. Okay, that's f of a. That's it. You're done. Should be an easy mark, right? F of 2x. Okay? Wherever there's an x, now I'm going to make it a 2x. That's it. So x cubed becomes 2x cubed minus 2 times x, but it's not x, it's 2x. Okay? You done leaking, Leon? Good. All right. Little bit of review. Does this exponent 3 apply to the 2 and the x? Anything, everything in the brackets? Okay. So I got 5 times 2 times 2 times 2, which is 8, times x times x times x, which is x cubed, minus this one, just 2 times 2 times x. Okay? So I can collect 5 times 8, that's 40, x cubed minus 4x. Can I collect those? Are those like terms or unlike terms? Unlike. Don't try to collect them. It's not 44x to the 4 or something silly like that, okay? This is pineapples. That's grapefruits. It's not a pine fruit or a grape apple, okay? It's a pineapple and a grapefruit. You can't collect them, right? Unlike terms. Don't try. Okay. A little bit bigger, a little bit uglier, okay, but it's exactly the same procedure. What do we do? This is a function p of x, all right? I don't know what it means, but it means something. I don't want p of x, I want p of x minus 3. Everywhere where there's an x, there and there, I put in x minus 3, okay, in its place. So I have 4, not x squared, x minus 3 squared, minus 6 times x, but not x, x minus 3, plus 1. Okay? Now we're back reviewing some polynomials. I want to simplify this. Okay, that's right for the first step, but it's not simplified. Okay? How do I do, is this x squared minus 9? You said yeah. First step you should do is this. X minus 3 squared is x minus 3 times x minus 3, right? That's a binomial times a binomial. We better get 4 terms there, not 2 terms. Okay, minus 6x, I can just work this out. Negative 6 times negative 3 is positive 18 plus 1. Okay, I got to keep going. This isn't simplified. And again, we got choices. Okay, do we want to FOIL that first, then multiply everything by 4, or do we want to get rid of that 4 first? I think last time I FOILed it, so you know what? Let's do it this way. I want to get rid of that 4. Okay, I want to tuck it inside the brackets. Don't do it to both, just do it to one. So that's 4x minus 12 times x minus 3. Okay, now I'm going to FOIL. Okay, first is, I still have all this other stuff, right? Okay, 4x squared minus 12x minus 12x, and last is negative 12 times negative 3, which is plus 36. I still have this stuff. I'll collect 18 and 1, make it 19. Okay, I got some more collecting to do. How many x squared terms do I have? Just that guy. X's, I got minus 12, minus 12, that's minus 24, minus another 6, that's minus 30. Okay, and then lastly, I just have these two numbers. What's 36 and 19? 55. Okay, that's the final answer simplified. That's as hard as they're going to get. Okay, so determine the value of x if f of x is 47. Is that different than anything we've done so far? Think psychology. Why is he asking the question? There's f of x. Remember, if I gave you something like this, f of 3, we plug in 3 where the x is. It's telling me what is the value of x. They're not telling me x is 3, are they? They're saying what is x if this whole thing is equal to 47. Okay? So here's what I got to do. I got to solve this for x, right? They're saying the value of the function is 47. What is x? You see how that one's different? Okay? It gets confusing from what I've noticed. Okay? So that's different, right, than what we've been doing. So how do I solve this for x? Well, add 3 to both sides. Okay, 3 take away 3 is nothing. 3 and 47 is 50. 10 times what is 50? Yeah, it's 5. But, you know, let's just solve it because they're not always going to look that easy. X is 5. Okay? That's what x is to make this whole function equal to 47. Now quickly, let's check it. If I work it backwards like everything I've done up to now, if x is 5, I want to check this. 10 times 5 is 50, minus 3, is that 47? Yes. Okay, it better work, right? Or I did something wrong. Okay, solve the equation. F of x is minus 23. There's f of x. It's 10x minus 3. They're saying f of x is minus 23. Okay? So read it carefully. Are they asking for x? Or are they asking for what the value of the function is? Okay, so add 3 again, both sides. That's minus 20 is 10x. 10 times what is minus 20? That happens to be negative 2. Okay? So we can only ask you two things. Either we tell you what x is and say find the value of the function, or we tell you the value of the function and say find x. And some people find that confusing. Okay, just a couple more. Here's some function x. X squared minus 5, where x is all real numbers. All right? That means there's no restrictions on x. Okay? By the way, if x was negative here, well, it ends up being positive, doesn't it? Because we square it. F of 4. One of two things is happening. Either we're telling you what x is and saying find the function, or we're saying this is the value of the function, find x. Which one is it? You got to know the difference. That says f of 4. That means 4 is x, right? X is 4. What's the value of the function if x is 4? What is 4 squared? Take away 5. What's 16 minus 5? That's 9. Do we see how b is different? Solve the equation. They're telling you this function is equal to 4. You see the difference? Because if you don't, I don't know how else to explain this. All I can do is say it again. Okay, you got to see the difference there. Yes? Yes. Thank you. 16 minus 5 is in fact 11. Someone's paying attention, and it's not me. Okay? How do I solve this? Well, I got to know what x is. First, get rid of the 5. Add 5 to both sides. Okay? So 9 is x squared. What is x? What squared is equal to 9? That's not the only answer. So again, if this was Pythagoras, remember a c squared. I don't want c squared, I just want c. Take the square root. Whatever you do to one side, do to the other side. But, have I told you this before? You got to take a plus or a minus here, because there is something else other than 3 when multiplied by itself to give us 9, right? That number is minus 3. Because negative 3 times negative 3 is also 9. Okay? There's two answers here. Okay, got two choices. All right. Last one, solve the equation f of t is 75, where t is greater than 0. So now the domain isn't all numbers, everything, everything. Okay? If this last question said that, could I have both answers here? No, one of them is not greater than 0. I would have to go, I can't use that one because that doesn't obey this domain. All right? And then we want this in simplest radical form. More review. Radicals. Nice. Okay? So f of t is 75. There's my function. This is still the same question, right? Okay? So f of t, this is function of t. That's t squared minus 5, but this is equal to 75. Okay, so we're throwing kind of two things at you at the same time. First, we're changing x to t, then we're telling you the value of the function. Okay, so t squared minus 5 is 75. How do I solve this for t where t is positive? Well, add 5 to both sides. So t squared is 80. I don't want t squared, I want t. How do I get rid of that squared? By taking the square root. So t is root 80. Do I want to go plus or minus though? Because it says t's positive. T's has to be positive. So in this case, I don't want the minus. Okay, I just want the positive value. Okay? So I'll write that. Positive only. Okay? But did I fully answer the question? Is that simplest radical form? Or can I write it a little nicer? How do I do this again? Is there a perfect square in 80 I can take out and make it a mixed? Okay? And do I want to find the largest perfect square or just any old perfect square? Let's pretend the only one I see here is a 4. Okay? So that's root 4 times root 20. Right? That's the same as root 80. Why do I do that? Because I know the square root of 4. Okay? But is there another perfect square in here? Yes, there is. So this is root 4. I know I can make that 2. I'm writing it out like this because I just want to. Root 20 is root 4 times root 5. So if I wanted to find the largest perfect square, well, I could have went like this. 16 goes into 80 5 times. And the square root of 16 is 4. Okay? So in simplest radical form, as a positive answer, that's my answer. Okay? And sure, you could have went here and went, well, that's 2. And that's 2 times root 5. Well, that's 4 root 5. It's the same thing, isn't it? Okay? Alrighty? 1 to 13. Should be pretty quick. Sorry? Well, I'll stop this and I'll